Hi, welcome to Dissolve Chemistry. So, in the series of thermodynamics, in the previous video we have discussed regarding state function and path function. In the today's video we will discuss regarding work, energy and heat. So, as I have written on the board that work on one side, heat on other side and energy at the center. What is the reason for that? You will be clear at the end of the video. Let us define what do you mean by this work first. Well, what do you mean by work? Suppose if you are lifting a stone, so then we call it as work has been done. How? Say for example, when you are lifting that stone means you are displacing that object against the gravity pull. Okay. So therefore, what do you mean by this work? We define this work as displacement of an object against the external force, what we call, or we call it as what? A process of, we can include like this, a process of achievement of motion against external force, we call it as work. A process is said to be done work when the object is lifted or it is being taken to a certain height. If you are taking to greater and greater height means you are doing more and more work, we say that. Say for example, let us consider an expanding gas, a process of expansion of the gas. So we call it as it is doing work, and that we can realize when the expanding gas is assumed present in a cylinder fitted with a piston. So the gas present in that is, as it is expanding, then this process of expansion of the gas leads to the movement of the piston or rising of the piston against the external force. Then we call that gas has done the work. Okay, we will take one important mythological example that Hanuman has lifted a mountain to bring Sanjeevani. So that lifting of mountain is an example of doing work. Say for example, if I say the same thing to you people that you just go and lift the mountain, then what you will say? So that we don't have that power or capacity to lift the mountain. Then what is capacity? So that capacity we call it as what? Your energy. Energy is what? Capacity to do work. When I said Hanuman has lifted the mountain, then why can't you? Then you say that we don't have capacity. Means capacity means what? Capacity to do work is nothing but your energy. You don't have that energy what Hanuman has. So therefore you can't lift the mountain. So therefore now let us we will define together that as next term, that is energy, which we call it as what? Capacity to do work. Capacity to do work. Okay, capacity to do work is nothing but your energy. Okay. So now for example, we will take the same thing that instead of this expansion, if you compress the gas in an isolated system, you take this as an isolated system. What do you mean by isolated system? This which cannot exchange both heat as well as matter with the surrounding. So that we call it as what? Isolated system. So therefore initially your piston is here and you are compressing this gas. Now what we can call? The capacity to do work by the gas now has been enhanced. Or simply we can say that its energy is raised. Energy is raised, we call. Fine. Okay. So energy or capacity to do work has enhanced means if you allow the piston, once again what happens? It will move back to here. Okay. Means what we call now? the piston has, or the gas, compressed gas has done the work we call. After expansion, if we further expect the gas to expand, its capacity has been reduced. Due to expansion, its capacity to do work has been reduced. Okay, so that is how we are going to define energy. Now let us move on to the next term. So that is heat. See, you kept a container containing, say for example, water, okay, on a burner, or you can call it as your gas stove. So over that you have kept a container containing water. Okay, it contains water. Now what happens? The energy which is released here is being transferred into this. Okay, so previously we have said that capacity to do work means the energy is being harnessed in the form of work. Many experiments have shown that it is not only the way in which the energy is going to transfer, there are many other ways. Like for example, the flow of energy occurs from higher temperature to the lower temperature. That is, transfer of energy will take place from higher temperature to the lower temperature. So that we call it as what? Heat. When the energy flows from hotter end to colder end, then we call it as what? Energy has flown in the form of heat. Heat is what? Process. Okay, heat is not an entity, it is a process by which energy flows. Simple example we will take. Cup of tea. Okay, so cup of tea, so what it will do? So hot tea means, what is the meaning of this? It is at higher temperature. So if you keep it in the surrounding, then what happens? Its temperature will decline, meaning is what? Heat has flown out, or energy has flown out, because here it is high temperature, outside is low temperature, so therefore energy will flow, and this flow of energy is called as heat. Okay, similarly, when you go for preparing the tea on the flame, okay, you have taken a container, in that you have added whatever the ingredients supposed to be added, and you start what? When the flame is on, then heat will move into the system. From the surrounding, heat is absorbed. Okay, so then what happens? The tea is being prepared, and the same tea, when you put it in a cup, then what happens? Heat will flow, because it is at higher temperature. Now energy will flow. Okay, you should remember, very important thing is, heat is not a entity, it is a process. Okay, next move on to the next topic, that is we call this heat will move due to difference in temperature when into the system or out of the system, when the wall is thermally conducting, means heat, if it transfers in and out through a walls, okay, such wall we call it as what? Diathermic wall. The next term we should understand is diathermic walls. And there are certain walls, okay, which won't allow the heat either to enter, energy to enter in or out of the system. Such walls are called as adiabatic walls. Okay, we call it as what? Adiabatic walls. So now I hope that you have understood what do you mean by work, what is energy, and what is heat. So what do you mean by diathermic walls, adiabatic walls? Now we will see that many processes which will take place, particularly chemical reactions. So we call it as, we categorize them into two classes based on the transfer of heat as exothermic and endothermic processes. Exothermic process and endothermic process. During many chemical processes, the energy flow will take place in and out of the system. Based on that, we are categorizing them into endothermic and exothermic processes. What do you mean by exothermic process? During a chemical reaction or a process, if heat is given out, then we call it as what? Exothermic process. If during that process, if heat is absorbed, then we call it as what? Endothermic process, or energy is absorbed in the form of heat during that process. We call it as what? Endothermic process. Now next important thing is this exo and endo. We will discuss in a diathermic walls, system having diathermic walls and system having adiabatic walls. Say for example, we are carrying out a chemical process in a container with adiabatic walls. Now I think you are clear with what do you mean by adiabatic walls. Adiabatic wall means it is completely insulated such that it cannot transfer heat with the surrounding, or there is no flow of energy due to difference in the temperature. So now suppose if you do some chemical reaction, okay, you carry out an exothermic process in an isolated, or we call it as adiabatic wall container, then what happens? Energy of the system is going to increase. Why it increases? Because during that chemical reaction, a energy is evolved, okay, in the form of heat. So therefore, the temperature of the system increases. Okay. So whereas if the process is endothermic, then what happens? The temperature of the system decreases, because during that process what happens? Energy is absorbed. Okay, whatever the energy is there within the system, that all being utilized to bring that endothermic process which is carried out in a adiabatic walls. Now similarly we will carry out that in a diathermic walls. A system which is having diathermic walls, suppose if you carry out exothermic process, then what happens? The heat is given out to the surrounding, or energy in the form of heat is given out. Okay, heat is given out to the surrounding. Whereas if you carry out a endothermic process, okay, so endothermic process, okay, in diathermic walls, then what happens? Heat is absorbed from the surrounding. What happens? System will, what it will do? System will absorb the energy from the surrounding. Whereas if it is exothermic, heat is given out to the surrounding. Means heat is flowing from system to surrounding, here from surrounding to system. Okay. So when the heat flows from system to the surrounding, then we represent that by negative sign. And if heat is absorbed from the surrounding by the system, then we represent that by positive sign. Okay, right. So I think you are clear with all these three concepts. Now I hope that why I have written this energy at the center. Work is also process, heat is also process, during which there will be an exchange of energy will takes place. Because of that reason I have written at the center. Okay, I hope you have understood the concept what I have discussed today. So in the next video we will talk about further aspects of the thermodynamics. Till then, thank you. Bye.